Welcome to the Foundry by Forge College. Let's jump right into this explainer. So, if you've been following our Solidity from Zero track, you know we literally just wrapped up a pretty deep lesson on designing inheritance hierarchies for reuse. In that one, we were totally focused inward, right? Organizing how our smart contracts share code and storage behind the scenes. But today we're flipping the script. We are shifting our focus completely outward. We're going to look at how to define formal external-facing Solidity interfaces. Think of it like graduating from designing the actual kitchen to finally publishing the menu.
Okay, so let's kick things off with a fundamental question. How exactly do completely independent contracts, or even off-chain clients like your wallet or a block explorer, securely communicate with your code without needing to know a single thing about how it was actually built? I mean, in the decentralized world of Web3, it's not like you can just call up another dev and ask, hey, how does your contract work? No way. We need a strict, absolutely guaranteed way to communicate.
Here's our roadmap for understanding stable contract APIs today. First up, the interface concept. Second, breaking down the code. Third, the golden rules. Fourth, comparing interfaces to abstract contracts. Fifth, real-world APIs. And finally, conclusion and next steps. Let's get into it.
Section 1. The interface concept, featuring our trusty restaurant menu analogy.
Honestly, the absolute best way to wrap your head around what we're building before we even peek at a single line of code is the restaurant menu analogy. Picture this. On one side, you have the menu. The menu tells you exactly what dish you can order, the main ingredients, and what's going to show up at your table. That, my friends, is your interface. It's a promise. Then, on the other side, you've got the kitchen. The kitchen is your implementing contract. It's doing the actual cooking, storing the food, chopping the veggies, the whole shebang. The beautiful part here, the menu never ever tells the kitchen how to cook the food. It just guarantees the customer what they can order.
So, looking at the formal definition, a Solidity interface is a compact declaration of externally callable functions and events. It guarantees a stable signature surface without prescribing the implementation. In hardcore engineering terms, we're talking about a pure application binary interface, or ABI. It completely standardizes the outside view of your contract. Anyone reading this interface knows exactly how to format their transaction to talk to you, no guesswork involved. Moving on to Section 2, breaking down the code, specifically the syntax lifecycle.
So, how does this actually look in code? Well, there's a very specific three-step lifecycle when you're using an interface. Step 1. You declare the interface using signatures only, just the names, parameters, and return types. You're basically just printing the menu. Step 2. The implementing contract swoops in, provides the actual logic, and uses the override keyword to tell the compiler, hey, I am fulfilling the promise made on the menu. And Step 3. The caller interacts safely via the ABI, just blissfully unaware of the concrete details going on inside your kitchen.
Taking a closer look at the syntax itself, check out this simple line of code. Notice how it ends? With the strict semicolon. There are absolutely no curly braces here. No function bodies are allowed. Period. You are literally just stating that a function named increment exists. It takes an amount, and it can be called externally. Full stop.
All right, Section 3, the interface golden rules. Time for some strict compiler laws.
Now you gotta understand, the Solidity compiler is incredibly strict about interfaces. It's kind of like that one friend who refuses to split the dinner bill unless the math is calculated down to the exact penny. There is zero wiggle room. Here are the ironclad laws you have to follow. First, as we just saw, absolutely no function bodies allowed. Second, you can only use external visibility. Third, no state variables whatsoever, because remember, the menu doesn't store the food. Fourth, no constructors, since initialization is strictly an implementation detail. And fifth, this one's actually pretty cool. Interfaces can inherit other interfaces, which lets you build massive modular menus out of smaller ones.
Let's zoom in on that visibility rule for a second, because it definitely trips up a lot of developers. Why external only? Well, external visibility ensures interfaces define exactly how other accounts and contracts call the implementation. Think about it. If the compiler allowed internal or public visibility inside an interface, you'd be mixing up your internal inheritance family secrets with the public-facing ABI. The compiler straight up forbids it to keep your external boundaries perfectly clean.
Next up, Section 4, interfaces versus abstract contracts and choosing the right blueprint.
This is a massive distinction, and it comes up all the time for devs going through our Forge College learning tracks. When do you actually use which blueprint? Let's break it down. An interface allows no function bodies, no state variables, no constructors, and only external visibility. It is strictly the menu. But an abstract contract, that allows function bodies, it allows state variables, it allows constructors, and it allows any visibility. An abstract contract is basically like a partially prepped kitchen. It's a base contract that has some shared logic and storage ready to go, but it still needs a derived contract to come in and finish the job. Bottom line, if you need to share storage or internal logic, go with an abstract contract. If you just need to standardize an external call, use an interface.
Moving right along to Section 5, Real-World Smart Contract APIs, featuring ERC20 and plugins.
Let's take these strict classroom rules and see how they actually enable massive real-world ecosystems. Take scenario A, internal utilities. Imagine you've got a bunch of plugin contracts that all need to read configuration flags from a central registry. If those plugins rely on an interface, let's call it iRegistry, they are locked into a beautifully stable ABI. What does that mean for you? Well, tomorrow you could completely rip out the underlying registry implementation to make it 100 times more gas efficient. And as long as your new registry still conforms to that exact same iRegistry interface, none of your plugins will break and you won't even need to recompile them. It's a real game changer.
And that same logic scales up to the entire Ethereum ecosystem. Get this, ERC20 is just an interface. Yeah, it's a mind-blowing realization for a lot of people. The ERC20 token standard that literally powers billions of dollars in value? Fundamentally, it's just an interface. It's simply a list of function signatures like transfer and balance of that wallets, block explorers, and decentralized exchanges all agree to use. They frankly don't care how your specific token contract works under the hood, just as long as it correctly serves up the items on the ERC20 menu.
But here is the crucial warning you absolutely need to remember. Interfaces lock the ABI. They do not lock the behavior. The interface guarantees that a function called transfer exists and that it takes an address and an amount. But, and this is a big but, the interface absolutely cannot guarantee that the function actually moves tokens. A malicious developer could totally write a transfer function that just steals your funds. Semantic guarantees, meaning proving that the contract actually does what the interface implies it does, those still rely heavily on thorough testing, documentation, and auditing. So stay vigilant.
Almost done. Section 6, Conclusion and Next Steps. Let's prepare for implementation.
We have covered a ton of ground today. Let's quickly recap the 3 core principles you need to take away from this explainer. First, interfaces declare the what, not the how. They are the ultimate implementation-agnostic API. Second, forcing external visibility creates a completely stable ABI for third parties to rely on. And third, if you ever find yourself needing to share state variables or internal helper functions, that is your cue to switch from an interface over to an abstract contract.
Which leaves us with one final, very important question for you. Are you ready to implement your own interfaces and verify that your ABI matches expectations? Well, in our next lesson in the track, Implementing Interfaces and Contracts, we're going to be doing exactly that. We'll write different storage strategies that all conform to the exact same external interface. To continue this journey, jump over to forge.college. We have a massive library of resources, interactive modules, and an amazing community waiting to help you master these concepts and everything else in Web3. Thanks so much for joining me for this explainer by Forge College, and as always, keep building.